My name is Mark Alley. I'm a clinical assistant professor at North Carolina State University College of Veterinary Medicine. My primary role is about 60% teaching, 35% extension, and 5% service. So what we did is we had one operation at one of our research facilities at North Carolina State where they had, it appeared to be that the cattle were not responding to the feeding program that they were using in the trial. And what we did then is we went in, took some fecal samples just on some random calves, and I realized that there were still a lot of parasite eggs being produced even though they had just recently been dewormed. Then our next step was to go through and just to see, have a more controlled type of study to figure out if it was in just the 10 or 15 calves that we checked or if it was a problem in the entire group. And once we got started, we decided that we would be best to actually design a trial comparing different products in that particular operation to see what the results were going to be. This particular herd is about 160 cow registered Angus herd on a research facility in North Carolina. The one thing is that particular farm had a history of different types of ivermectin products being used for the past 25 years at various times, both on the cows and in the calves themselves. So we decided we were going to use the fecal egg count reduction to determine what was going on this particular farm. What we did is we used a protocol very similar that the NOM survey from USDA used for theirs, where we took an egg count or a fecal sample from one particular calf, came back in 14 days later and determined what the egg counts were after they have had their treatment. Our plan in this particular project was to not only look at what it was doing on this farm, but it was also to look at several different products. So we divided them up into different types of ivermectins. We also had a control group so that we could tell what was going on within the group. And then our final group was a fenbendazole group. Our pre-treatment egg counts were averaged, and we were over 300 eggs per gram in most of the calves. This was a group of calves that were between 6 and 8 months of age. The trial was done in July, and the calves were born between December and January of 2007, 2008. What we did is, after we randomly selected those calves and put them into their treatment groups, we called day 0, which was the day of weaning. We went in, took our fecal samples. The calves had already been assigned to treatment groups. They were also weighed on the day of weaning. Then those calves were given their appropriate treatments, whether it will be a topical product, injectable product, or an oral product, or then the control group. Any of the calves that received any kind of a topical product were all isolated. So we had a generic product and then a brand name product that we used together. Those groups were isolated and separated from the other two, or from the other 3 groups. So the injectable, oral, and the control group were all housed together. 14 days later, we come back in to take fecal egg counts again, and then that's how we determine what the fecal egg count reduction was on each individual calf. So pre-treatment, we had a fairly high parasite egg count in each of the groups. We had about 300 eggs per gram in each of those. Post-treatment, we had a variation depending on which product we used. In the generic, topical, an injectable brand name product, and a topical pour-on, all of those groups had less than an 80% reduction in egg count. With the fenbendazole treated group, we had a 100% reduction in our fecal egg count with that group. In addition to the fecal egg count, we were also able to do a PCR to determine which species were present both in the pre-treatment group and the post-treatment group. In the pre-treatment group, we had Haemachus, Ostratasia, and Coperia parasites available in each group. With the post-treatment group, we had Coperia present in all treatment groups other than the fenbendazole. The big conclusion that we had from this farm is on this particular farm, we had a less than a 90% reduction in fecal egg counts across any of the ivermectin products that we used. With the use of the fenbendazole group, we had a 100% reduction in our fecal egg counts, and based on the results of the PCR, it appears that Coperia was the primary parasite remaining in all of our ivermectin treated groups. With that information, what we will do is we will try to begin determining which of the groups or which of the farms need to do some fecal egg count reductions that would give them an idea as to how their particular product is working on their farm, and then that will allow us to help better customize a control program for that particular farm. We actually repeated the project at another farm in North Carolina, and on that particular farm, regardless of which of the products or treatment classes that we use, we got greater than a 90% reduction in our egg count. That led us to believe that these potential issues are farm specific, and each farm needs to address what is going on with the population of parasites on their farm.